So the protected mode is unlike the previous one, unlike the our real mode memory architecture, protected mode memory architecture is actually they are using 32 bits, because previous one is using 16-bit and we have some problem with the 16-bit, but now in protected mode they are using 32 bits. By the way, the first time this protected mode was actually added in 80286 processor, and I think know that it's actually invented, or it is first launched is 1995. So the previous mode, that means the real mode, is they actually launched in 1978, long ago. So the protected mode, if you think about the launching date, the protected mode is updated version or updated memory architecture compared to the real mode architecture. All right. So, and also that's why that is one of the reasons that after this protected mode from 802x's, 3x's, 4x's, and the all other 86 x86 architecture. By the way, I hope you know what is x86 architecture. That means it's 32-bit processor. All of the 32-bit processors, they actually call x86 architecture, especially the Intel one. So Intel, if the Intel has any processor of 32 bits, they call the family as x86 architecture. That means all the 32 bits Intel microprocessor, they actually follow, most of them follow this protected mode memory architecture. Okay. And of course it is widely used because of its very memory efficient and faster implementation. Okay. But some of the system, that is also true at the same time, some of the system using both of them. I think in the book they also said that some of the system they actually using, I mean, mixed mode. It's called mixed mode. That means sometimes it's use this one. See, mixed mode operation. So sometimes they're using that one, sometimes they're using this one, both of them. All right. So we are not going to discuss this mixed mode, but we just need to know that most of the processor, especially the 32-bit processor, they're using the protected mode memory architecture because there are some new feature on it. First feature is virtual memory. We know what is virtual memory. That means virtual means always, that means we don't have physically, but we can assume that we actually have. So we have virtual memory, we have paging, and we also have multitasking. By the way, they call it safe multitasking because some of the multitasking is really not, I mean, good for the performance. That's why some of the processor actually don't implement these multitasking tools, because whenever they do multitasking, they are coming forth and like doing like this actually hamper the or reduce the performance. Okay, but they say that this is actually safe multitasking. Fine. And the reason behind this is the operating system, and that means our system can have more control and access over our application software. Okay, so that is the main reason. So just remember, in protected mode memory architecture, this was started in 286, that means 80286 family, and then most of the x86 architecture, that means all of the 32 bits microprocessor from Intel, they actually using this protected mode because it's widely used, it is more efficient, it is upgraded version, and if you think about the performance, it's actually quite good. Okay, and why it is more efficient and more popular? Because it's actually added more uh, tools, as I said, virtual memory, paging, and multitasking. Okay. All right. So there will be so many Ajan. I don't know where actually I should stop. Let me just stop for 1 minute. Okay. I'll come back after 1 minute. Just and actually we are discussing is about protected mode, and I told you before that is unlike the previous one, is actually using the 32-bit address. Okay, and most of the, as I said also, that most of the Pentium processor or X30 X86 family, they are actually using this one. And another important thing is actually also support the segmentation, which is very important. By the way, you might thinking that what is actually paging, right? The paging is actually one kind of memory management system or tool by which the paging is using some virtual memory, right? Some of the virtual memory means like logical memory, and those logical memory um, um, refer or connected to the original physical memory. But as I said, some of the pages, that means there might be multiple pages. By the way, each of the address they call pages. So some multiple pages or multiple logical address may be connected with one physical address, unlike the previous one, right? Previous one was one logical address may be connected with one physical address, but here there might be multiple one. Okay, so what is paging is actually, as I said, paging is a virtual address depending on the process. Different process has different address, different process has different paging information. So these pages actually come and forth to the main memory and to their virtual memory. So that is the pages is actually increase the operations and increase the efficiency also, because sometimes, not always, because the previous one, the real mode memory architecture, is actually very old technology. That means one logical address has generally one physical address. Sometimes it is really not efficient because we have so many applications. Okay, so we actually cannot, I mean, serve all these applications at the same time. So this, in that case, paging is a very good tools, because each of the application has their own paging information. Whenever it's possible, it's actually go to that memory location and come back again and give the space for the other pages or other application. Okay, so that is actually paging. Very good. And another thing is, unlike previous one can do only 1 MB of memory, the real mode. But here the protected mode, they actually can use and allocate memory location and the address within the 1 byte, and of course more than the 1 MB of memory. All right, that's why our current Pentium processor, most of the processor, they're using this protected mode. And as I said, some of the system actually using both of them. For example, whenever you start your first computer for the first time, maybe they is starting with the real mode memory architecture, and then it is actually switches to the protected mode memory architecture in the mixed mode. Okay, so that is the scenario. And in this protected mode, there are two more important information. There are so many other types of things, but I'm just giving you these two important information. One is the descriptor, another one is the selector. Let me show you one picture from the book. If you remember about our segment register, do you remember our segment register? In our segment register, we have 6 segments, right? We have 6 segments, and each of the segments store some of the memory location. Okay, but let's say, for example, you write it here 101010, and then whenever the processor actually comes here and thinking that, okay, is it a physical memory address, is it a direct memory address, or it is what? So each of the address should have or must have a description. All right, a description. That's why if you think about more elaboration of our 6 segment register, you can look at this picture, this one. So previously we actually know that only we have this, but it is also, there is another part called invisible part. Don't worry about this one. Why actually I'm showing this, because each of the segment in the 6 segment register, they actually have the data inside their register is called selector. They store information regarding those active memory, and that information is called selector, right, into the segment register. So into the segment register, selector is saved. All right, selector information. So you might thinking that what is a selector? Selector is one kind of information which can be derived or can be get from one of the descriptor table. Okay, there is another term called descriptor. So we saved a selector into the segment register so that the processor can understand which are the active memory. But whenever you go deep to that information about the selector inside the segment register, you can see that selector is actually getting the value from one of the descriptor table. So now the question is, what is the descriptor? Very normally and generally, descriptor is the description of the memory location, length, length of that memory location, and also access rights. This table, address, limit, base, and all other types. Okay, so the two things, that's why I'm giving the told you that there are two things. One is the selector, one is the descriptor. Let me just summarize one more time that in our segment register, right, in our segment register, and we told you before that each of the segment store the memory location of currently active segment of the memory, right? That is the information we know already. So if you know, if you just try to analyze more about this, the data is saved into this segment register, we can see that each of the segment register is actually store an information which is called selector, the name selector. So what is a selector? Selector is actually getting located in the one of the descriptor table, So what is a descriptor table? The next question is, descriptor is the description, all right, of the location of the memory, length of the memory, and of course the access right of the segment of the memory. All right, so that is the descriptor. Fine. So generally we have two types of descriptor. That is the last information. There are two types of descriptor. One, it is called global. Another one is called local. Very easily, global descriptor, that means this is one kind of table. This table, this description table, is actually only describe those kind of memory location which are actually has a system information, all right, only for the system. Let's say operating system, utility software, device driver software, this kind of thing are actually the description has in this table, which is called global descriptor. Another one is called a local descriptor, right? In the local descriptor, they saved the user application, right? For example, the user application, for example, in this table, they actually stored this information that in which memory location this our PowerPoint is saved, in which memory location our Adobe Reader is saved, all right, into the local descriptor. That means in the local descriptor, they saved those memory description which related to application, user application. Whereas the other side, in the global descriptor, they store those kind of memory information where the system related information is stored into that memory segment. Okay, so that is the two types of descriptor. So please remember that we have two types of extra thing, descriptor and selector, and we can get it from this 6-segment register. So again, to very summarize everything about the protected mode memory architecture, that it is very popular. It was first invented in 1995 or more, something like that, and it is first launched is 80286 processor, and then the rest of the consequent, subsequent processor actually using this memory architecture because it's updated one, because it has more efficient, and it is also very good for the other one. And also another reason is it actually added some of the new features, for example virtual memory, paging, and multitasking. Okay, that's why it's very popular. And unlike the previous one, which is the real mode memory architecture, it is using 32-bit address, and it can use 1 megabyte and more than 1 megabyte of the data because it has 32 bits memory address. So, and after that we have discussed what is the paging is. The paging is actually one kind of virtual memory where we have so many virtual memory depending on the different types of application, and several virtual memory location can be referred to one physical address. That is the paging. And in this process, the protected memory mode process, we actually have two more extra thing, although we have so many others, but I'm actually selected these two one because these are the most important one. One information is the selector because it is saved into our 6-segment register. So they store this selector information. And what is selector? Selector is actually loaded from the descriptor table, and the descriptor is the description of the memory location. We have two types of descriptor, global and local. One is for system and another one is for application. All right, so that is the protected mode memory architecture.